Assalamualaikum and hello everyone. So today we are going to discuss questions on chapter 3, electric current and direct current circuit. Okay, let's start. State Ohm's law and sketch VI graph for ohmic conductor. Okay, when it says state Ohm's law, you need to know the definition of Ohm's law. Ohm's law is the potential difference across a conductor, which directly proportional to the current through it if its physical condition and the temperature are constant. So it's really important for you to write physical condition and the temperature are constant. Okay? Alright, next question. Sketch VI graph for ohmic conductor. So when we need to sketch VI graph for ohmic conductor, it means that ohmic conductor obeys Ohm's law. Obey Ohm's law. And if it's obey Ohm's law, we will get straight linear graph. And V against I, which this is voltage with the unit V and also current with unit A. And we know V over I is constant. And from this graph, we know the gradient of VI graph is resistance. So therefore, V over I is resistance. When we rearrange this equation, we will get Ohm's law equation, which is V equals to IR. Alright, next question. A 6 ohm resistor is placed across the terminal of 12 volt battery. So you have a 12 volt battery and the resistor is placed across it. So this is your battery with 12 volt and your resistor is 6 ohm. Okay, first question. Current flows through the resistor. So we need to look for the current. So we can use the Ohm's law equation, which is V equals to IR, where our voltage is 12 volt and we are looking for the current and resistance is 6 ohm. And we will get the answer of 2 ampere. And next question. Magnitude of charge pass through the resistor in 2 seconds. So we need to find for the charge that pass through the resistor in 2 seconds. And we know the current that flow through the resistor is 2 ampere. So we know the current flow is 2 ampere. I equals to Q over T. We arrange this equation, we will get Q equals to IT, where we are looking for the Q and our current is 2 ampere and our time is 2 seconds, which will give a 4 coulomb. Alright? And please remember to write your unit. For the figure 1 below, calculate the current flows through 20 ohm resistor. As you can see in figure 1 here, there are 3 resistors. And resistor for 20 ohm resistor is the resistor 1. So we need to calculate the current flow through resistor 1. And we also need to find for the potential difference across each resistor. So we have 3 resistors here, so we need to find for V1, V2 and V3. Okay, for this question, I will solve it in a table form. So let's start. Okay, first of all, you divide to 3 columns. So this column you will have diagram, you will have resistance, and you will have current and voltage. Okay? Alright, first of all, we need to look for the total resistance. The other word for total resistance is effective resistance or equivalent resistance. So this will have a same meaning, total, effective, or equivalent. Okay, let's start with the first, and then let's start. We will look for the total resistance. So as you can see from the diagram, we have resistor 1, 2 and 3. Okay, first of all, we need to solve for resistor 2 and 3, as resistor 2 and 3 is in parallel. So when it's in parallel, we will use this equation 1 over R23 equals to 1 over R2 plus 1 over R3. Then you substitute your resistor 2 with the value given and resistor 3 with the value given. You will get 60 ohm. So when we are done, we are going to combine resistor 2 and resistor 3. So these resistors, when we combine, will become resistor 2, 3. Now resistor 1 and resistor 2, 3 is in series. So when it's in series, we can find for the total resistance by using formula R1 plus R23, and we know resistance of resistor 1 is 20 ohm and resistance of resistors 2, 3 is 60 ohm. So this will give us 80 ohm. The total resistance is 80 ohm. Now when we solve it, this will be your first step, your second step. So we will do it from up to below. Now we are going to solve it from below to up for the current and voltage. So now this is going to be your third step. Okay, now we know this is series circuit. So when we talk about series circuit, we know the total current will be the same with current that flow to resistor 1 and current that flow to resistor 2, 3. While the voltage will become V, we need to add for the voltage, and for the resistance we need to add as well. Okay, now let's look. The first thing that you need to do is to solve for the total current. We need to look for the total current. So how do we do it? So we use the Ohm's law equation, which is total voltage equals to total current times by total resistance. And we know our total voltage is 240 volt and our total current is, we are looking for it, and our total resistance is 80 ohm. And when you press your calculator, you will get 3 ampere. As we know, this is series circuit. So when this is series circuit, the total current will be the same for the current to flow through resistor 1 and resistor 2, 3, which is 3 ampere. Okay, now we are done with step number 3 and we'll go for the step number 4. We are going to look for the voltage. So as you can see, this is parallel circuit. When it's parallel circuit, it means that they have the same voltage. So voltage 2, 3 is the same as voltage 2 and the same as voltage 3. So we are going to look for voltage 2, 3. As we know, the current for I23 and also resistor 2, 3. So current that flow through resistor 2, 3 is 3 ampere. And the resistance of resistor 2, 3 is 60 ohm. We already calculated here. And when we press the calculator, we will get 180 volt. Okay, so therefore, the current that flows through 20 ohm resistor is 3 ampere. As we know, this is series circuit. And resistor 1 has 20 ohm ampere. So they will be the same, so 3 ampere. And as in for the voltage across resistor 1, 2 and 3, we know for V2 and V3 they are in parallel. So when they are in parallel, they will have the same voltage. As in for the voltage across resistor 1, we can look for it. So V1 equals to I1 R1, and our V1 is, we are going to look for it, and our current is the same, so it's 3 ampere, and our resistor 1 is 20 ohm. So we'll press the calculator, we will get 60 volt. Okay. Alright, consider the following circuit. What is the total equivalent resistance of the circuit? As you can see in this circuit, this is the combination of series and parallel circuit. Okay, in order to tackle this kind of question, we need to solve it one by one. Okay, let's look. R3 and R4 is in series. Okay, R3, R4 is in series. Okay, then we will combine R3 and R4. So we will get the diagram like this. Okay, now here we become R3 and R4. Here will still become R2, R1 and R5. Now R2 and R34 is in series or parallel? Yes. R2 and R34 is in parallel. So R2, R34 in parallel. Okay, then when we are done, we will get R1, R2, 3, 4 and R5. So R1, R5 and R234. So R1, R234 and R5 is in series. R1, R234 and R5 in series. Now, when we already decide which circuit it is, then we can solve it easily. Okay, let's do one by one. So the first one is R3 and R4 in series. Therefore, R34 equals to R3 plus R4. And we know resistance of resistor 3 is 4 ohm and resistance of resistor 4 is 1 ohm. Therefore, we will get 5 ohm. Okay, we are done with the first step. The second one is R2 and R34 in parallel. So this become 1 over R2 plus 1 over R34. So we know the resistance of resistor 2 is 3 ohm. Resistance of resistor 34, we already find for it, is 5 ohm. So we will get R234 15 over 8 ohm. And next one, R1, R234 and R5 in series. So we will look for the total resistance. So the total resistance is R1 plus R234 plus R5. So it will become resistance of resistor 1 is 5 ohm. Resistance of resistor 234 is 15 over 8 ohm. And resistance of resistor 5 is 2 ohm. So when you press the calculator, you will get an answer of 7 over 8. Okay, so you will get 7 over 8 ohm. Alright, let's look at the next question. Determine the following quantities for each of the two circuits shown below. So we will have the first circuit is this one and the second circuit is this one. Okay, let's look at A first. So we need to look for the equivalent resistance, means we need to look for the total resistance, and we need to look for the current from the power supply, means we need to look for the total current and we need to look for the current through each resistor. So from the circuit here, we know we have 3 resistors, so we need to look for the I1, I2 and I3, and we need to look for the voltage drop across each resistor. So we need to look for V1, V2 and V3. Okay, first of all, in order for you to tackle this question, you need to figure out whether this is series circuit or parallel circuit. So as you can see here, this is series circuit. So I will label this as resistor 1, resistor 2 and resistor 3. So it will be easier for us to solve this question. Okay, now we need to look for the total resistance. As we know, for the series circuit, the total resistance is just R1 plus R2 plus R3. So we know the resistance of resistor 1 is 20 ohm, resistance of resistor 2 is 30 ohm, and resistance of resistor 3 is 50 ohm. So this will give you an answer of 100 ohm. So we are done with the first question. Okay, the current from the power supply. So we know that it asks for the current from the power supply. It means total current. So we can use Ohm's law. So total voltage equals to total current times by total resistance. And we know our total voltage is 125 volt. And our total current, we are going to look for it. And our total resistance is 100 ohm. So when you press the calculator, you will get an answer of how much? The answer of 1.25 ampere. So we'll get an answer of 1.25 ampere. Alright, we're done with the second question. So let's look at the third question. So for the third question, the current through each resistor. So as we know, this is series circuit. So when it comes to series circuit, we know the current is the same. So the total current is the same as the current that flow through resistor 1, current that flow through resistor 2, and current that flow through resistor 3. So as we already got the answer for the total current, therefore our total current is the same with I1, I2 and I3, which is 1.25 ampere. Okay, and next we need to look for the voltage drop across each resistor. So the voltage drop across each resistor, we can use the formula for voltage across resistor 1 equals to current flow through resistor 1 and resistance of resistor 1. So we already know our current that flow through resistor 1 is 1.25 and resistance of resistor 1 is 20 ohm. So when you press the calculator, you will get an answer of when you press the calculator, you will get an answer of 25 volt. Okay, next one. Voltage across resistor 2. So we know the current that flow through resistor 2 and we know the resistance of resistor 2. So the current is 1.25 and resistor 2 is 30 ohm. And we will get an answer of 37.5 volt. Alright, now we need to look for the voltage across resistor 3, and we know the current that flow through resistor 3 is 1.25 volt and the resistance of resistor 3 is 50 ohm. So when you press the calculator, you will get an answer of 62.5 volt. So we are done with question number 4. Alright, let's look at next question. Determine the following quantity for each of the two circuits. We are done with the one of the circuit. Now we're going to look at the second circuit. So first of all, you need to determine whether this is series circuit or parallel circuit. So as you can see here from the diagram, this is parallel circuit. Okay, now we need to look for the equivalent resistance. We need to look for the total resistance, the current from the power supply, the total current, and current through each resistor. As we can see here, we have 3 resistors and we label this as resistor 1, resistor 2 and resistor 3. So current through each resistor and also voltage drop across each resistor. Alright, let's look for the equivalent resistance. So we know if you're looking for the equivalent resistance for parallel circuit, the formula is 1 over R total equals to 1 over R1 plus 1 over R2 plus 1 over R3. So we know resistance for resistor 1 is 20 ohm, resistance for resistor 2 is 100 ohm, and resistance for resistor 3 is 50 ohm. Press the calculator, you will get an answer of 12.5 volt. 12.5 ohm. The unit for resistance is ohm, yeah? Okay, now we need to look for the current from the power supply. We are done with question 1, we go into question 2. So the current from the power supply is total voltage equals to total current times by total resistance. And we know our total voltage is 125. And we are looking for the total current, and we know that our total resistance is 12.5. So you will get a total current of 10 ampere. Okay, alright, next question is the current through each resistor. So for parallel circuit, they don't share the same current. As in for the series, they share the same current, but for parallel, no, they do not share the same current. So we need to look one by one. But before we can find for the current, we need to know voltage across each resistor. So I will answer question 4 first, then only I will answer question number 3. Okay, voltage drop across each resistor. So one thing that you need to know that when it comes to parallel circuit, they share the same voltage. And we know the total voltage is 125 volt. Therefore, the voltage across resistor 1, voltage across resistor 2 and voltage across resistor 3 is the same as the total voltage, which is 125 volt. So I already answered number 4. Then only I'll answer number 3, the current through each resistor. So you can use the formula of V1 equals to I1 R1. So we are looking for voltage across, we are looking for the current that flow through resistor 1. Okay, so we know the voltage across resistor 1 is 125 and we are looking for the current flow, and we know resistance of resistor 1 is 20 ohm. So when you press the calculator, you will get an answer of 6.25 ampere. Same goes to this one. We know the value for voltage across resistor 2. We are looking for the current that flow through resistor 2, and we know the resistance of resistor 2. So we know the resistance of resistor 2 is 100 ohms. So the current that flow through resistor 2 is 1.25 ampere. Alright, the same one goes to resistor 3. We know voltage across resistor 3 is 125. We are looking for the current, and resistance of resistor 3 is 50 ohm. So when you press the calculator, you will get 2.5 ampere. Determine the current in and the voltage drop across each resistor. Okay, now as you can see from the circuit here, we have combination of series and parallel circuit. Therefore, we need to solve it one by one. So let's see. We know R2 and R3 is in parallel. R2, R3 in parallel. So then we know we will combine resistor 2 and resistor 3. Then we will get, here become resistor 2 and resistor 3. Here will become resistor 1. Here will become resistor 4. So resistor 1, resistor 2, 3 and resistor 4 is in series. Okay, my question is, why do we need to find for the total resistance? Okay, we need to find for the total resistance so that we can find for our total current. And from the total current, we can look for the current for each resistor as well. So let's do step by step. Okay, first step, we need to look for the total resistance. Okay, now we know R2 and R3 in parallel. So this is the formula, 1 over R2 plus 1 over R3. So our resistor 2 is 8 ohm. Resistance of resistor 3 is 8 ohm as well. So this will give us 4 ohm. Okay, this will give us 4 ohm. Alright, now, and then we know R1, R2, 3 and R4 is in series. Therefore, R total equals to R1 plus resistor of 2, 3 and resistor 4. So our resistance of resistor 1 is 5 ohm, and then resistance of resistor 2, 3 is 4 ohm, and our resistance of resistor 4 is 6 ohm. So they will give a total resistance of 15 ohm. Alright, from here we know this is series circuit. So I'll label this diagram as 1 and 2. So this is series circuit. So when this is series circuits means we will have the same current. So we can look for the total current first. So we can use Ohm's law. Total voltage equals to total current times by total resistance. And we know our total voltage is 60 volt. And we're going to look for the total current, and our total resistance is 15 ohm. So our total current is 4 ampere. Okay, now as we know R1, R2, 3 and R4 is in series. So when it is in series, they will share the same current as well. Total current equals to current that flow through resistor 1 is the same as current flow through resistor 2, 3 and current flow through resistor 4, which is 4 ampere. So we know our I1 is 4 ampere, our I4 is 4 ampere. Now, when we already know our current that flow through resistor 1 and resistor 4, we can look for the voltage. So we know V1 equals to I1 R1 and V4 equals to I4 R4. So current that flow through resistor 1 is 4 ampere and resistance of resistor 1 is 5 ohm. So they give us 20 volt. Same goes to this one. Current that flow is 4, resistance is 6. So they will give us the answer of 24 volt. Okay, now we are done with resistor 1, we are done with resistor 4. Now we will look at resistor 2 and resistor 3. We need to look for the current flow through resistor 2 and 3 and voltage across resistor 2 and resistor 3. We know resistor 2 and resistor 3 is in parallel. So when it's in parallel, they don't share the same current, but they share the same voltage. So we know V23, we can look for it, current that flow through resistor 2,3 and R23. And we know current that flow through resistor 2,3 is 4 and the resistance is 4. So we'll give us 16 volt. And we know the voltage for parallel is the same. Therefore, V23, voltage across resistor 2 and voltage across resistor 3 is 16 volt. Okay. Now, as we already know the voltage across resistor 2 and resistor 3, we can look for the current by using Ohm's law formula. So, we know voltage across resistor 2 is 16 volt. We are looking for the current and we know resistance of resistor 2 is 8. So, the current flow through resistor 2 is 2 ampere. And next one, we are looking for the current that flow through resistor 3. And we know voltage across resistor 3 is 16. And the current that flow through resistor 3, we are looking for it. And resistance of resistor 3 is 8 ohm. So, it is 2 ampere as well. So, we already looked for the answer. It's a bit messy, I'm sorry, but okay. We already have the current that flow through resistor 1, current that flow through resistor 4, current that flow through resistor 2, and current that flow through resistor 3. We also have voltage across resistor 1, voltage across resistor 4, voltage across resistor 2 and 3. Right? Okay, next. Study the following electric circuit and find the current flowing in the circuit. Okay, now, so we have a series circuit. So first of all, like I told you before, in order for us to find for the total current, we need to look for the total resistance first. Okay, let's look for the total resistance. So this is series circuit. Okay, so total resistance is R1 plus R2. So I will label 10 ohm resistance as resistor 1 and 20 ohm resistor as resistor 2. So total resistance will become 10 plus 20 equals to 30 ohm. Then we can use Ohm's law formula to look for the total current. So total voltage equals to total current times by total resistance. And we know our total voltage is 3 volt. And we're looking for the total current. And our total resistance is 30 ohm. So our total current is 0.01 ampere. Okay, can? Oops, I'm sorry, it's 0.1 ampere. Okay, next we need to look for the potential difference across 10 ohm resistor. So it means we need to look the potential difference across resistor 1. So we can use this formula. Voltage across resistor 1 equals to current that flow through resistor 1 times by resistance. Resistor of resistance 1. Okay, now, do we know that current that flow through resistor 1? No, we don't know. But we know this is series circuit. So they share the same current. So total current is the same as the current that flow through resistor 1 and current that flow through resistor 2. So therefore, current that flow through resistor 1 is 0.1 ampere. So that's 0.1 and resistance of resistor 1 is 10 ohm. So we will get an answer of 1 volt. Alright, thank you everyone. That's all from me.